A time for class. Today, I will give you the lecture An Introduction to Green Building. My name is Liu Guifeng. First, I want to understand your language. Two problems. One, do you learn Chinese? Two, explain I lecture to students in Chinese daily. So, I'm not get used to speaking English in class, though I can. I think as a graduate student in Chinese university, you'd better learn and master Chinese. Okay, now begin to class. An Introduction to Green Building. 4 problems. Big one. The building, the development background, and the concept of green building, including small 1, small 2, small 3. 1. The development background of green building. 2. Concept of green building. 3. The development of green building at home and abroad. Big 2. Chinese 2. The design philosophy and design method of green building, including 2 problems, small 1, small 2, big 3, Chinese 3. The subject basis of green building, the technology category of green building, promotion and development model in China. 4. Big 4. The library of Shandong Construction University. For example, the library is green building. Big 1. The development background and the concept of green building. Small 1. The development background of green building. 1.1. Overview. In recent years, China's social and economic development has constantly increased the demand for natural resources, resulting in large energy consumption, lack of water and soil resource, large carbon emissions, and severe smog. Building energy conservation is widely concerned. In the process of building design and construction, advocate maximum resource saving, environmental protection, and energy consumption reduction As a new seeking and mode, green building is more and more widely used. (1.2) Status quo. Look at the drawing. Construction site drawing. Big house, big building. The second drawing, outdoor environment in China a few years ago. Urban haze. It's horrible, it's terrible. Outer environment, greenhouse effect is coming. It causes global warming and catastrophic climate. For example, Arctic warming, melting ice and snow. Out environment will acceleration of urbanization, large energy consumption, land and water resources are in short supply, serious urban pollution, large carbon footprint. These drawings indoor environment, air conditioning disease. Relying on air conditioning, consumption of electricity is not good to health. So air conditioning disease will come. Decoration materials contain formaldehyde, benzene, and other harmful gases to human body. Energy consumption in construction. Building consumption, including 30% natural materials, sand, stone, soil, and so on. 40% of energy, cow. Global architecture generation, 30% of solid waste, 20% of sewage, and 40% of carbon dioxide. In addition, noise pollution. According to statistics from June 2016, nearly 2 billion square meters of new houses appear in China every year. In urban and rural areas, more than 8% of which are energy-intensive buildings. So we want to know what's the green building? Green building is high-tech buildings? No. Is high-cost building? No. It's a building greening? No. So we can understand the definition of green building. According to Chinese evaluation standard for green building, the addition of green building is. This is an important definition. In the whole life cycle of a building, it can save resources to the maximum extent. Energy saving, land saving, water saving, and material saving. For savings: energy, land, water, and material. Protect the environment and reduce pollution, so as to provide people with healthy, applicable, and efficient use space, and build a harmonious coexistence with nature. This is the definition of green buildings. You can understand it. The definition includes three main factors: the whole life cycle. For conservation, one, environmental protection. Adjust matters to local. About the definition of green building. The green does not only mean that the general sense of three-dimensional green building roof garden, but represents a concept or symbol, refers to the building that is harmless to the environment, natural environment. Resources can be fully used, and the basic ecological balance condition without destroying the environment to build a building, but also refers to as the construction of sustainable development, ecological construction, return to nature, energy conservation, and environmental protection, and so on. So you can understand the definition. I'm sorry. I'm, I can't understand. What's happening? I can't understand. Okay, construction failures. Construction failures, including 4. Location, location, pollution-free, non-toxic, better address, suitable temperature, moderate earth magnetism, material selection, you speak after class, okay? Three, energy utilization. Make full use of renewable energy, solar power generation, heating and heating, wind power generation, discharge control. Therefore, control the discharge of domestic sewage and wastewater, controlling carbon dioxide emissions, rainwater recovery system. This is construction failures of green buildings. A green building, including 3 sites: clear design concept, specific technical support, operational evaluation system. A green building has the difference with the general building. This problem including many problems. Closed. The green building is effectively connected with the outside, integrated with the natural environment, and can be adaptive, adjusted according to climate change. Resources. Green buildings is regarded as a kind of resources which can create maximum development benefits at the minimum ecological and resource cost. Energy conservation. Green building can reduce energy consumption and generate renewable resources. It is a zero energy consumption and zero emission building. Style. The green building adopts local material, respects local culture traditions, and presents different styles according to climate, natural resources, and cultural differences. 4. Green building starts from harmony with nature, develops sustainable, and achieves diversity and richness of form. The last one, time. Green building can provide healthy, suitable, and efficient space for human beings in the whole life cycle. Small 3. The development of green building at home and abroad. 3.1. The development of green building abroad. In the 1960s, American architecture Paul Solaris proposed a new concept of ecological architecture. In 1969, American architect Len MacArthur wrote the book Design and Nature, which remarked the official birth of archaeology. In the 1970s, the oil crisis made solar energy, geothermal, wind energy, and other building energy saving technologies emerge at the historic moment, and energy-saving buildings have become the pioneer of building development. In 1980, the World Conservation Organization first put forward the slogan of sustainable development. Meanwhile, the energy-saving building system has been gradually improved and widely used in Germany, Britain, France, Canada, and other developed countries. In 1987, the United Nations Environment Programme published the report, Our Common Future, which established the idea of sustainable development. In 1990, the world's first green building standards were issued in Britain. In 1992, the United Nations Conference on Environment and Development promoted the idea of sustainable development, and green building gradually became the development direction. In 1999, the Green Building Association was founded in the United States. In 2000, Canada introduced green building standards. Okay, 12 countries have global green building evaluation system now, include China. 3.2. The development of green building of China. Since 1992, the Chinese government has issued a number of relevant guidelines and regulations to promote the development of green buildings. The launch of National Green Building Innovation Award in September 2004 marked that China's green building development had entered the stage of comprehensive development. In 2006, the Ministry of Housing and Urban-Rural Development officially promulgated the Green Building Evolution Standard. This is the first evolution standard in China. In March 2006, the Ministry of Science and Technology and the Ministry of Construction signed a cooperation agreement on green building science and technology action. In August 2007, the Ministry of Housing and Urban-Rural Development issued the technology rules for green building evolution and the administrative measures for green building evolution marks. In 2009 and 2010, in May 2012, there are many things happen of green buildings. The last one, on April 15, 2014, the Ministry of Housing and Urban-Rural Development officially promulgated the new evolution standard for green building. This evolution standard is used now. It's the second evolution standard. This is a drawing for Egg Industrial Park in China. A plan drawing. Index system of ecological park includes 4 index. 1. Economic development indicators. 2. Characteristic indicators of ecological industry. There are many indicators. 3. Ecological environmental protection indicators. There are many indicators here. You can read it carefully. For green management indicators. Such as policy, regulations, and system indicators, and so on. Many. The 2 drawings, the 2 photos. This explains eco-industrial park is surrounded by greenery. The environment is beautiful. This is the environment of Bovary Ecological Park. These drawings explain the environment for agriculture park. (3.3) Green building development in Jiangsu Province. The city of Changzhou is in Jiangsu Province. As a student in Changzhou University, you can understand the green building development in Jiangsu Province. 1. The green building development history in Jiangsu Province from 2005 to 2012. Two drawings. The regional distribution of green buildings in Jiangsu Province. Changzhou City is the fourth. The first one is Suzhou City. The second is Nanjing City. The third, Wuxi City. The city of Changzhou is the fourth in Jiangsu Province. This includes the number and the square of green buildings. The three drawings, the status of the project, total numbers, 510 square, 5,420. Changzhou is the fourth. Suzhou is the first one. Wuxi the second. Nanjing the third. Changzhou is the fourth. Big 2. Design principles and methods of green buildings. This problem includes two parts. 1. While ensuring the performance, quality, life, and cost requirements of the building, give priority to the environmental attributes of the building. 2. Fundamentally prevent pollution and save resources and energy. 2. The time span considered in the design is large and involves the entire life cycle of the building, that is, from the preliminary planning of the building, the formation of the design concept, the construction, the use of the building, to the disposal of waste after the building is scrapped. Two key points of green building design. The first one, for the building itself, the efficient use of resources and the use of environmentally friendly building materials are required. 2. To consider the surrounding environment of the building to adapt to the local climate, physical and the geographical conditions. Small one, 3 principles of green building design include 3 parts. 1. The 3R principle of resource utilization. 2. Environmentally friendly principle. 3. Principle of locality. First one, the 3R principle of resource utilization. 3I, reducing, reusing, recycling. 3R. 2. Environmentally friendly principle. It means, first, design the environment within the area. 2. The surrounding environment of the design area. Scope includes 3 parts. First one, indoor environmental quality. 2. Outdoor environmental quality. The last, impact of surrounding environment. 3. Principle of locality. They include 3 parts. The first one, respect traditional culture and local experience, and pay attention to inheriting and developing local history and culture in the design of green buildings. 2. Pay attention to the combination with the regional natural environment and adapt to the natural process of the site. 3. Use of local materials, including plants and building materials. Small 2. Wait a minute.
你知道我去签拿钥匙就给我了。我们师傅他又不知道，他以为你是上课的。那我也不知道，你不能怪我这样。对。啊。他说他们也有这个要出来的，他们是借了教室的。正在上课呢，能不能换一个？我现在正在上中文课堂，他不在。他倒是吧，他倒是在学校，他倒是吧。不好意思。因为你们要教室的话，不需要写机械进来，因为他们叫窗户的那个是。然后他就看到这边是空的，因为一看这地方没人就来了，是后悔的，没看。
A little thing. Small 2. Green building design process and design methods include 3 parts. The process of integrating design. Second, life cycle design method. The last one, participatory design approach. The first one, the process of integrating design. Composition of the overall design. In this process, ensure that requirements and objectives are considered. Emphasize the overall process. Evolution scheme. Developing distinctive solutions to meet requirements and goals yields multiple benefits. Develop assessment to help identify needs and set goals. Look at the building as a whole. Focus on life cycle design. Work as a team from the beginning of the design. Levels of public participation. This includes 8 parts. Public participation. You can fully participate in, can symbol in, no participation. First one, no participation include 2, manipulated participation. Educational participation. Symbol in include 3. Consultative participation. Restricted participation. Cooperative participation. Fully participate in include 3. Representative participation. This is 7. 6. Cooperative participation is 6. 8. Decision participation. The second levels. Big 3. The subject basis and the technical category of green building research. Small 1. The scientific basis of green building research include 8 parts. The first one is green building culture and history. 2. Basic theory of green building. 3. Basic knowledge of green building technology. 4. Green building analysis. 5. Green building design. 6. Design techniques and support tools. 7. Green building evolution. 8. green building operation and management. This is the scientific basis of green building. Small 2. The green building design category. This is include 3 parts: architecture, equipment, and building materials. Architecture includes many sites: green building planning, exterior wall, Zabno insolution, energy saving window, natural light control, architecture shading, natural ventilation, the double curtain wall, roof greening, vertical greening, resource conservation, structure system. Equipment includes many sites. For example, rainwater collection and utilization, new energy hot water system, water saving appliance, solar photovoltaic power generation system, and so on. Building materials. 4 sites. Conventional green materials, recycled materials, local building materials, special functional building materials. Green building design category. Green building planning. 3 parts: site selection, distribution, and outdoor environment. 2. Energy saving measures for the peripheral structure. External wall insulation, energy saving windows and doors, sunshade system, roof greening, vertical greening. 3. Efficient use of energy. For example, there are many problems here. Efficient use of energy. Energy efficient air conditioning systems. Large temperature difference air conditioner. Converter technique. High energy storage technology. Energy saving lamps and lanterns. Last, intelligent lighting control system. 4. Comprehensive utilization of water resources. The nature infiltration of rainwater, rainwater collection and reuse, utilization of water, water saving instrument. 5. Indoor environmental quality. Natural ventilation technology. Natural light control. Operating fresh air system. Green building material. Material saving building materials. Material recycling. Resource conservation structural system. Renewable energy utilization. Application of solar energy. Application of geothermal energy. Wind power utilization. Biomass energy. Green building technology composition and means. 1.3 Green building technology composition. 1, 2, 3, 4, 5, 6. 6 parts. The first one, safe ground and outdoor environment. Second, energy conservation and energy utilization. Water conservation and water resource utilization. Material saving and material resource utilization. Indoor environmental quality. Operations management. Classify. A green building technology type. Low to high, hard to soft, high to low. Green building technology composition and means. Safe ground and outdoor environment. For example, permeable ground. Barrier-free facilities. Could-lane design. Reasonable space control. Three-dimensional affording green transport and ground space utilization. Outdoor original ecological protection. Sound acoustic environment simulation analysis. Site wind environment simulation analysis. Field light environment simulation analysis. Site thermal environment simulation analysis. And light pollution control, and so on. Soft turn to hard. Low should able change to high. Energy conservation. Natural lighting. For example, window wall reseal control. Optimized design of natural ventilation. Environmental refrigerant control and environmental impact calculation. low E glass, solar heat 等等。You can look at this PPT. Natural lighting includes low E glass, solar heat, fixed sunset, background lighting, planting roof, cold roof, and so on. Adjustable internal seating, integration of photoelectric building, and so on. Water saving, recipients, water saving irrigation. You can use rainwater collection and utilization, water saving appliance, constructed wetlands, reuse the reclaim water, the rain to regulate, seawater utilization, use of condensate water in air conditioning. In addition, ecological landscape water, ecological restoration and maintenance, matter, water system planning, zero emission design. Soft, gentle, hard, low, suitable, high, suitable, material saving and material resource utilization. Simple modeling design, package decoration include recycled material, regrown material, fast-growing material, recyclable material. You can use steel structure, high-strength material, timber work, necessity analysis of space function, flexible partition, local materials, deep classification and collection of garbage. You can use RCC calculation, optimization analysis of structural material saving. Indoor environment, day lighting control, pollutant control, natural light, regulating facilities, acoustic environment, compensation measures, monitoring of carbon dioxide and carbon oxide. Smoking room design. You can use air quality control, central fresh air system, adjustable external seating, barrier-free facilities, thermal comfort control, environmental protection material control, and pollution monitoring. Low technology, suitable, high. Operations management of building. Energy metering. Property management system. Management incentive mechanism. Energy metering. Energy consumption monitoring and analysis. Garbage compression by chemical treatment. Building intelligence, and so on. Collection system debugging. 3. Promotion and development mode of green building in China. This problem includes 3 stages. The first one, green building industry cluster demonstration area. The second stage, green building demonstration room, national and provincial level. 3 stages, demonstration and evolution of green monomer building. Green building industry cluster demonstration area. Green building industry cluster demonstration room is the product of green building and green economy development mode, seeking for symbiotic development in a certain region. It is development under the guidance of the concept of invigorating the city by industry and integrating the industry and the city to explore what kind of industry type is used in a specific region. For example, Wujing Green Building Industry Cluster Demonstration Area. Wujing is a part of Changzhou. Wujing区is a part of Changzhou. 2. Hebei Green Building Industry Cluster Demonstration Area. Green Building Demonstration Room, national and provincial level. National Green Building Demonstration Area. Guangming News District, Shenzhen. Shenzhen is a big city. It's a super big city in Guangdong Province. Guangming New District is built in 2008. Huai'an, an ecological new city. Huai'an is a city in Jiangsu Province. This district is built in 2011. Beidaihe New Area. Beidaihe is in Hebei Province. Building Energy Conservation and Green Building Demonstration Room, Jiangsu Province. Jiangsu Province. 2010 Green Building Demonstration Area. 10. 2011 Green Building Demonstration Area. 8. 2012 Green Building Demonstration Area. 11. 4. For example, a green building of Shandong Jiaotong University. It is a library. A library is a green building. Application of green building design cases. Shandong Jiaotong University Library. In 2007, the Library of Shandong Jiaotong University was awarded the first prize of Green Building Innovation Award by the Ministry of Construction. It is a green building evolution marking project. Program creation began in the second half of 2000, completed in 2002, and put into use in 2003. This is the library. The building is modern. The building is a modern campus building. It is 5 floors. It is 5 floors, and 1 floor underground. 1, 2, 3, 4, and 1 floor underground. Total construction area of about 15,700 square. These drawings explain the library. This is its west side. This is the north side. This is south side. It's a site. North, south, west, east. West, it's north, this one, south, this one. Sunset, design and practical effects of west-facing exterior wall siding. This can reducing air condition energy consumption in summer. This is the south side. Southward horizontal lower shading and effect. Energy conservation. East retreated shading. Roof grill shading. The shading effect of the south side courtyard. Waste tube inside the shading. Horizontal sun visitor. The transition period. Natural ventilation. Ventilation strategy of different seasons. Summer to pilot underground air ducts. 45 meter and 85 meter. Buried depth 2.5 meters. Wind speed is 0.45 meters second. 2 parallel underground air ducts, 2 45 meters and 1 85 meters buried depths, 2.5 meters. Wind speed is 0.45 meters per second. Side out of wind. Pull the wind chimney lever to bring out the wind. The atrium roof. Peel out the wind funnel. This facility. Ventilation louvers in the sides and the interior spaces. Good. The outer window can be opened on the roof of the side courtyard for hot pressure ventilation. These windows can be opened. North-south ventilation shutters. Night ventilation shutters. Low windows easy to open manually every night. Ceiling window on interior partition. Ceiling window on interior partition. The smoke control system with natural ventilation is designed and developed by ourselves. Room ventilation floor. Low grill, naturally ventilated room. High grill. Design of natural ventilation purse. Natural ventilation process. You can find the in the drawing. CFD technology was used to simulate the effect of natural ventilation in transition season. Simulation conditions: outdoor air temperature, (26). Outlet air temperature, 70 terminal celsius. Horizontal solar irradiance, 6,000. Terminal air cooling technology. To 45-meter long terminals and one 85-meter long terminal. (2 meters wide and 2.5 meters deep. Underground. After the fresh air is preheated through the terminal, it is sent to the air conditioning box for treatment. Save energy on air conditioning, save energy on air heating. Terminal vent double pipe 1. Terminal vent double pipe 2. Terminal air duct. Section air 4. Square. Design the air value 6,500. Natural lighting reduces lighting energy consumption. The total lighting design load is 170 kW and the lighting density is 10.8 W every meters, according to the calculation of 15,700 square meters, mainly combined with natural lighting. The lighting power is reasonable reduced. The marginal areas take advantage of natural lighting. The attribute is natural light. Natural light in the side courtyard. According to the evolution method of simulated energy saving of reference buildings, considering matters such as terminal vent, water cooling, air conditioning system saves 20%, shading, natural ventilation, and natural lighting. The energy saving effected is 22% better than that of reference buildings. Water conservation and water resource utilization. Use pool water as cooling water. It greatly saves the cooling water of air conditioning. For example, the glass curtain wall on the daylighting roof above the coffee shop on the first floor is equipped with a sprinkler head, which can be turned on to cool down during the hot summer. The water sprayed on the glass curtain wall flows back to the circulating water pump room on the ground floor and is recycled after filtration. The cave feeders a waterscape consisting of a wall of water with a drop gap of 3 meters, a circular fountain, and a narrow channel connecting the two. The water in the cafe is also recycled. Rainwater collection and water recycling. The rainwater recycling. Material saving and material resource utilization. Excavated and abandoned stones from the site were used as retaining walls and paving materials. Structure optimization. This project is complex in modeling and unique in structure, involving a wide range of surfaces, including both concrete structure and steel structure. Concrete structure involves long span wall beam, and cantilever structure. Meanwhile, in order to cooperate with the artistic modeling of the building, some long-span concrete beams with complex shapes are designed. The rafter foundation and the foundation beam are designed according to the elastic foundation beam. The structure system adapts the reinforced concrete frame structure, and the stair and the elevator wall adopts the reinforced concrete wall. After careful calculation of the structure, the long cantilever structure and the long span concrete beam structure are adopted in order to resist the wind load and the earthquake load. The cantilever column is treated underwater so that the calculated length of the column is reduced. After optimization, concrete is converted to a thickness of 500 cm every square meter. Steel consumption per square meter. Reinforcement 17 kg per square meter. Three-dimensional roof graining. The roof is grained. Indoor or forest. Three-dimensional grating design. The Atriumia roof graining. The library is in North China. North China is cold in winter. The season is in winter. Window sill graining. Roof graining. Suitable for local graining species and tray and sublayer graining. The tray is often used in North China. The library is in Shandong Jiaotong University. Shandong Jiaotong University is in Shandong Province. Shandong Province is in North China. Lake water lake water. 60% permeable surface area, including water surface. Permeable surface area. Its site was originally a contaminated garbage dump that was converted into construction land. This is construction. The library, the original Steinkai Reservoir will be transformed into campus waterscape to improve the ecological environment. After improving the environment, the library is very beautiful and useful. This building won the first prize of Outstanding Architectural Design of Ministry of Education. Won the first prize of the second Green Building Innovation Award of Ministry of Construction 2007, the first place. Awarded the Building Energy Conservation Annual Representative Project of Building Department in 2008. Obtained the first batch of 2-star green building in the certification in 2009. 4 prizes. 4 prizes. The wall is beautiful. This lecture is end.